Okay, question number 4. Okay, we have this graph here. The graph of the differentiable function f shown for x equals -6 to x equals -7 has a horizontal tangent at x equals -2. So something like here we have this, and is linear for t equals 0 to t equals 7. Let R be the region in the second quadrant bounded by the graph of f. The vertical line x equals -6 and the x and y axis. Region R has an area 12. Okay, so let's write that down. 12. The function g is defined by gx equals 0 to x ft dt. Find the values of g, -6, 4, and 6. Okay, so this problem mainly uses the two fundamental theorem of calculus. Okay, let's see. G, you're being asked to find g -6. So basically we just substitute -6 and these values into the x. So first, g -6 equals to 0, -6 ft dt. So this is a little bit inverted, so let's reverse that order. -6, 0 ft dt. But we need to add a negative sign behind it. Okay, so the area -6 to 0 under the function ft. So this part means that from -6 to 0, the area under the f curve ft plus a negative sign. So we were given that area. It is equals to 12. So the area is -12. Now let's find G4. G4 equals to 0 to 4 ft dt, and of the area from 0 to 4 under the f curve is a triangle. So let's find the area of this triangle here. So the base is 4 times 2 and divided by 2, which is equals to 4. So G4 equals 4. Now G6 equals from 0 to 6 ft dt, and we have to now separate the areas because 0 to 4 is positive and 4 to 6 is negative. Okay, so let's see. 0 to 6. Now it's 0 to 4 ft dt minus plus 4 to 6 ft dt. These two separate areas, one we have to add the one and subtract to that one. Okay, so 0 to 4 is still 4. 4 times 2 over 2, and 4 to the area from 4 to 6 is, so the base is 2 and the height is -1 over 2, which would make it this is 4 and this is -1. So 4 minus 1 equals 3. So the area under this curve is from 0 under f from x equals 0 to x equals 6 equals G6, which equals to 3. Okay, question B. For function g defined in part A. So this function. Find all values of x in the interval from x equals 0 to x equals 6 at which the graph of g has a critical point. Give a reason for your answer. So let's write that down. Gx equals this value. So gx equals from 0 to x t dt. Okay, now we need to find the critical point of g. So to find a critical point, we have to find g prime, so the function's derivative equals to 0. Find the x value. Okay, so first let's differentiate g. Now to differentiate g, we use g prime x. Okay, let's see. Now we have to use the derivative on this integral with the varying limit. Okay, now we just have to remove the integral and the derivative and replace t with x. This will do. So g prime x is equals to fx. Okay, so now we need to find g prime x equals fx equals to, when does it equals to 0? Which means gx prime x equals fx. So when is fx equals to 0? And now we're given the graph of f. And from the graph we can find that when x equals to 4, it equals to 0. So at x equals 4, fx equals to 0, g prime x equals to 0, and thus g has a critical point at x equals 0. So at x equals 0, gx has a critical point because g prime x equals fx equals to 0 at x equals 4. Question C. The function h, so new function, is defined as this. Find the values of h6, h prime 6, and h prime prime 6. So all its derivatives. Show the work that leads to your answer. So first let's find h6. h6 is equals to, so let's substitute 6 into x. So we would get negative 6 to 6 f prime t dt. Now from the fundamental theorem of calculus, this equation here is equals to f6 minus f negative 6. So what values is f6? It is equals to negative 1 given in the graph. And what is the value of negative 6? It is equals to a half, 1/2, so it's 0.5. Now h prime 6. So we first have to find the derivative of hx. So h prime x equals to what? So when differentiating integrals, we have to make sure this is a variable, which it is. Okay, so we can remove that integral and we can substitute that t to x. You also have to make sure that this x here is not a function, which is a composite function, x squared, for example. So h prime x equals to f prime x. Okay, now let's substitute x equals to 6. h prime 6 equals to f prime 6. So we need to find the slope at x equals 6 on this curve, and it seems that this is a straight line. So at x equals 6, what is the slope of the curve? Well, this is a line, so rise over run. This is rise is -1, so we decrease and we go right 2 units, we go down 1 unit, so it's -1 over 2. So h prime 6 is equals to negative 1 over 2. Now, what is h prime prime 6? So h prime prime x is now f prime prime x. And what is f prime prime x? At x equals 6. So h prime prime 6 equals to f prime prime 6. And, well, f prime 6 is equals to negative 1 over 2. It is already a straight line, so f prime prime 6 equals to 0 because h prime is a constant slope. Okay,